Howdy and welcome back. So let's say we have some sort of collection of movie objects serialized in CSV format, and we'd like to say we've launched up our application and we'd like to deserialize them back into their in-memory representation of movie objects. So what we're going to see here is essentially we're going to have to open up this file and go through it line by line and taking each of the lines and deserializing them back into a movie object. So the processing here is going to be in terms of CSV, because each record is stored on an individual line. We will process each line and construct a movie object from it. So how I'd like to begin. Let's just assume that we have a line, and this could have been read from the file. It could have been a string we created in an application, just kind of as a toy problem to begin solving this. But let's say we have something in this structured format. We have an ID delimited, followed by the title, with that field delimited with a comma, followed by a rating, release date, description. And what we like to do here is essentially get the ID into the ID field of a movie object. Out of this is a string of characters, okay? We'd like to then extract, say, the title and put it in its corresponding field in a movie object. We'd like to then extract, say, the rating and get it in its corresponding field. So on with the release date, it needs to go into the release date field of a movie object. And then finally, the description. Remember here, that last field is essentially going to be terminated with an end of line character because that's all of the fields for this particular record. So I'm kind of going about this, I don't know, maybe not the most readable way, but I'm saying, I'd like to be able to have some sort of movie object that, let's say, I create, and let's say this is a standard library string line. I'd like to be able to go M line to create that object. Okay, and this is just my preference. This is probably not the clearest way to go about it, but essentially, my idea here is, well, let's use the insertion operator to insert a line into a movie object. If you haven't seen this written like this before, you can see why it might have been a better preference to go ahead and create a function that handles it. But again, let's just highlight this route as well. So left-hand side of that operator is going to be a movie object passed by reference. Notice it is not const because we're actually mutating its underlying state. We're going from an empty movie object, or one perhaps with pre-existing data, into one that looks like this over here after we successfully read it, inserted the line to it. Cool. That means that the right-hand side operand to this operator is going to be just a constant reference to a string. In this case, I'm just calling that parameter line. And in this case, line would be used to initialize the line parameter. It's the argument to it, M, the M parameter. Okay, so let's decompose the body of this. What's happening? I wanted to make this as kind of easy to read as possible. And with that, it became a little cryptic at the same time. To populate the ID field, I'm going to call a function, which is going to return a string. Because this field contains an integer, I'm going to have to convert the in-memory representation is of type integer. I'm going to have to convert the string that's going to be returned by my function into an integer. But let's focus on this first. Here's the idea. I'm going to pass by constant reference the line to the file. I'm going to pass by address a integer object which stores which character I currently am on within this line. So each time this function returns, IDX is going to be updated to the current character that's under analysis. So let's see what happens when we invoke this function. IDX simply becomes a reference to the IDX that was declared in the insertion operator. std string substring is going to be an empty string. Now I have a for statement, which I'm essentially saying that as long as I'm less than the size of the string, I'm going to hit the body of this loop. And again, the size of the string is really the size of this line, because that's what was passed to our operator and then which was passed to substring from position to delete to initialize this string reference. So as I'm walking through, I'm going to essentially add characters to substring. The first time through, IDX is at 0. So we're looking at that character. IDX is less than the size of the string, so we hit the body of the loop. The character at this position is not a comma, nor is it an end of line character, so we know we're currently in a field, and we continue to process this. And each time we observe an actual character of the field, we push it back to substring. So at the end of this first call to substring from position to delete, we have a substring storing the character 1. That means that when we hit this line, IDX is currently at the comma, and I'm going to push it forward into the next field, just so it's out of convenience for the next time that I call this function, and then I'll return the substring. Remember that we have to go ahead and ensure that this string representation of 1 is converted to a integer, so calling string to integer, and then we successfully go ahead and store 1 within the ID portion of the movie object. So I've cleaned this up a little bit, so maybe the second pass through here will be a little bit clearer. After we've returned from the first call to substring from position to delete, IDX is going to be equal to 0, 1, 2 to the integer value of 2, which is essentially representing the third element in our string line here. So now we're going to go ahead and extract the data from the second field. So we want to go ahead and populate our movie field's title. So we call substring from position to delete with line and IDX. We hit the body of this function. String is going to be initialized as a reference to our line. IDX is essentially the address to this object, which then on this line, we essentially take a reference to that actual object. So at this point, IDX is simply another name for IDX here. Since the last function actually modified it, the starting value of this is going to be 2. We start out with an empty substring and we hit our for statement. While IDX is less than string size, in this case that evaluates to true, we hit the body of our loop. We check to see whether the character at this position is either a comma or a string. In this case, it's not, so substring is going to get G. G's pushed back to it. And then we hit an increment IDX and we move on to the next character. It is pushed back because we're not at the terminating condition, and continue on. And then we hit the space. W, I, let me pause and I'll come back with this done. And notice at this point, the substring is gone with the wind. We go ahead and increment IDX by 1. And guess what's at that character? A comma, which means we're going to go ahead and break out of our for statement. We will increment IDX by 1 so that we are into the next field. And we will return the substring, which in this case is Gone with the Wind. That is going to be used to initialize our title. So we'll successfully get Gone with the Wind into that field of our in-memory object. And we're going to continue this process for rating, release, date, and description. I'm going to kind of just recap what's going on here is with each call to substring from position to, I guess, delimiter. I've been calling it delete. I'm sorry. We're just looking at one field. So here it's 1. Second time through, we're looking at, you know what, let's do this even better. First time through, we're looking at the index field. Second time through, we're essentially looking at and populating the title field, as we've seen here. Third time through, I'm not sure if I'm getting these colors right, but rating to populate the rating field. Fourth time through, we're extracting the release date and putting it in the corresponding field in our in-memory representation. Fourth time field through, doing the same thing for the description field and ensuring that it's getting in the proper field in our in-memory representation. So with that in mind, the next step is, okay, well, if we're able to extract one of these, so from this string here, we're able to go to our in-memory representation. How can we do that for every single line within the CSV file? Well, it's not going to be that difficult. We can write a function called movies from CSV file, which takes the name of the file, binds that file to an input file stream, creates a new vector, which will store a collection of movies, and simply extracts a line from the file. So while there's a line in it, there's a movie object to get, pull it out, and go ahead and insert that line into our movie object M, push M back to our collection of movies, and continue this process until we've read the last line, after which we'll go ahead and return our collection of movies in vector form. So what that's allowed us to do is essentially run through this comma separated value format and deserialize each of the records within that file into an actual in-memory representation of a movie object. So we've simply said, kind of within our application, hey, get the movies from the CSV file. We'll go ahead and store that in a vector of movies. And after that function is done processing, our movies vector, in this case, contains 2 movie objects, Gone with the Wind, as well as Casablanca.